Okay, welcome back for our next module. Our next part of this is we're talking about operating systems and virtualization. This is still part of our computer fundamentals, our tech refresh, okay? Operating systems. When we think about operating systems, at the core of any operating system is this thing we call a kernel, okay? That the kernel, it really is. It manages the input and the output requests from software and translate those requests into instructions for your CPU. It's what also controls how information is written and retrieved from your long-term storage. So the kernel, very important part, really is the heart of your operating system. Then on top of that kernel, this is where we have application program interfaces and device drivers. This is the area that allows either your applications or us to be able to interface and talk to the kernel, okay? Our application layer. Now, on top of that, we have our operating system applications. Please do not confuse operating system applications with user applications. Operating system applications are things like your file manager, control panel, your shell. These are the things that if you just buy Windows 10 off the shelf, you install it. Those are the applications that are installed with Windows 10, not to be confused with Microsoft Office, which are user applications, okay? So like I say, so these are examples of your operating system applications, all these different things that you can do there. Like I say, with file manager or control panel, as well as your shell. Now the shell is a very important part, because why? It allows us to be able to interface via our application programs to interface with that kernel. Now, like I said, if you're a Linux guy or gal, you probably are very familiar with the different bash, the different shells, bash, there's several shells. Windows, now they've got PowerShell. Is also a way of actually in a text-based user interface to be able to talk with the kernel. And then, like I say, on top of this, which is not a part of the operating system, is your user applications, your Office products, Adobe, and all those, your games, all those different things. So when we look at an operating system, these are the core components of your operating system. Kernel, your applications, interfaces, device drivers, and your operating system applications, okay? So we talked about several things, right? We've talked about operating systems. We talked about the CPU. We talked about storage as well as memory, all these different pieces. All right, so let's bring all these pieces together. So when we think about it, like I said, we started with our non-volatile storage. Then we have our memory layer, whether it's our main memory, such as RAM or SRAM, our cache, layer 1, layer 2, and layer 3, as well as the CPU that's going to, the workhorse, right? So we, on top of that, this is where we have our operating system. Operating system is sitting on top of that, as well as our input and our output devices, which could be a plethora. Yes, I used the word plethora. It could be a plethora of things that we can use as I/O devices that will connect to it and control our input and output processes. So let's take a look at how this would work, right? Let's say that I've got some information, I got a document, okay, that I wanna update a Word document. Well, the kernel, within that kernel, that's what's gonna go to my hard drive, and it's gonna do a read function. It's gonna look at that hard, because here again, the kernel has built on this hard drive it's almost like a database, right? A storage of structure that it have basically cataloged every place on this hard drive, and it knows where information is stored based on the catalog. So it says, I'm going to go to this location or these locations, and I'm going to extract this information off the hard drive, and I'm going to bring it, and I'm going to send it to memory. So it goes into memory. From there, it goes and is written into our cache, and from there, it goes into the registers, and it starts that process, the fetch process, decode, execute, store. So that's working. So now we see how the operating system kernel via our input output devices goes hard drive, pulls data, brings it into memory, and once the process has been executed, goes back to our kernel, says process is finished. Now what do we want to do with it? I can send it back to an input output device, or I could write it back to my hard drive. I just want to save that. I just need to make an update and save it. I'm going to write it back to the hard drive. If I need to print it, I will send it to a printer based on the actions me, the user, have established. Okay, so that is how all of these pieces start to fit together. So from a security perspective, you see there's a lot of things going on. How do we keep track of all of these processes that are going on? Well, that's where the kernel does another thing. Okay, this kernel is also controls what we call your TCB, your trusted computing base. Okay, or reference monitor. You may hear these used synonymously. Your trusted computing base or the reference monitor in your operating system. So what this kernel starts to do is that it does a couple things. One, it controls access policy. Okay, now meaning that this controls who or what other applications or human processes have access to get to this hard drive, or have access to get to what folder on that hard drive. So that is set up right here within that kernel as well, or within that reference monitor of how information is accessed and what subject. If you remember from an earlier training, we talked about objects and subjects. Well, this is where that access control starts to take place, that which subject has access to which objects on our hard drive. Now, something else that the kernel does, it also, as each of these processes takes place within our computer, it assigns an identifier with that process. And you may see it as a PID. And what that allows from a security perspective is that now we can audit, okay? Because these activities, they're all captured in our system's audit log. So whether you're working on a Windows machine or it could be a Linux machine. Windows, we have the event logs, or whether it's a system, application, or security event logs in Windows. Well, all of these processes, they are being cataloged within one of those three areas. So that is how that's how we're able to audit activity, because each of the PIDs, each of the processes that are going on are being captured, cataloged. A code is established with each of those processes. For instance, if you are auditing a Windows machine, every time that somebody logs onto that machine, it's going to get a 2624 code is going to be assigned to that logon, as well as a log off. So there's just a large list of codes, and that's what our tools like Splunk and other logging tools are able to do, is now read those codes and tell us what type of activity is going on within this computing environment. So that's how the pieces fit together, and this is the why it's important to kind of understand this from a cybersecurity perspective. Okay, let's talk about virtualization. Now that we kind of understand how an operating system works, let's move into virtualization. First, what is virtualization? Virtualization refers to the creation of a virtual resource, such as a server. It could be a desktop, OS, a file structure, file system, or even a virtual network. Now, like I said, we just covered this traditional environment where you have what I call a tightly coupled traditional environment, where you have hardware, operating system, tightly coupled to that hardware, applications tightly coupled to that operating system. Like I say, it's one box, one piece of hardware, one operating system, and one set of applications. Okay, everything is tightly coupled together with that. Now, here's what happens. If you like many computers, many times these resources are really underutilized, especially the hardware. They're maybe only running at 10, 5, 6, 7% utilization. So that's why now when we look at a virtualized environment, which is a abstracted environment where we have hardware, and then we have other layers that we're going to get into a little bit deeper in the upcoming slides, that lets us do multiple things with that hardware and better utilize some of those underutilized resources that we are not using many times in a standalone machine. So like I say, this is our traditional environment. So when we talk about hardware, these are the components we're typically talking about when we talk about computer hardware, right? Within that hardware layer. The CPUs, the central processing unit, memory, we've talked about that, right? Such as RAM, SRAM, DDR, SRAM. Storage, could be a hard disk drive or SSD. Your network interface card, like we call them NIC, your NIC card, where it allows you to connect up to the internet. And all your different ports and your input-output ports, whether it's USB ports, HDMI ports, display port, all the different ports. All of these things are part of this hardware layer. And then, like I said, we talked about where we put an operating system on top of that hardware, whether it could be a Windows, Mac, Linux, whatever your operating system is, and then whatever user applications. Again, everything here tightly coupled together. You know, everything comes as a package once you get it built up. Now, in a virtualized environment, we start out the same. We start out with the same layer of hardware, right? We got the same layer of hardware. Now what we do, we'll put an operating system on this, and this is in a hosted, we call a hosted environment. So we have a host operating system. In this case, they say Windows 10. Windows 10 tightly coupled here. And then we have our Windows 10 or a host applications. Host application, Office, Adobe, whatever, Visio, whatever those are. Here's where we do something a little bit differently. Now we add a virtualization layer, a VMM, a virtualization machine monitor, or a hypervisor. You may hear it called hypervisor. There's multiple types of hypervisors. You can have VMware, VirtualBox. Windows comes with its own virtual machine monitor built in many times. Okay, so what does this virtual machine monitor do? Okay, this is where the abstraction takes place. So, like I said before, now you may look at this hardware and say, oh, there's extra capability. Let's say if I could have a quad core CPU. Well, I could have one core that's not being used. I could have, let's say I've got 64 or 128 gig of RAM. A lot of RAM that's not always being used just to support this operating system and these hosts, not to support the host. This space, you know, this could be a 1 terabyte hard drive, still a lot of space. Networking, this thing isn't on the network all the time, so I can share that. The same thing with my I/O ports. Many things can be shared. So there's excess capability, and there's a way to share these capabilities. That's what our VMM does. It actually says, okay, I see that you've got some extra hardware, CPU, memory, storage capability, then I'm going to share that out, as well as your network interface card and access to those ports. It actually now takes these same pieces of hardware and makes them available so that you can now install additional operating systems. Because an operating system, as long as it has access to a CPU, it has memory, it has storage, it can connect to the network, and has access to ports, it's happy. It doesn't have to be sitting right here, as long as it has access. So that's what this virtualization layer does. It provides access. So depending on how much resources you have here, you may be able to install multiple operating systems on top of that virtual layer. So to this guest, it's called a guest operating system. We have host operating system, host applications. We have guest operating systems, and when we install those, we can have guest applications. So this guest operating system doesn't care if it's sitting here or if it's sitting there, as long as it has access to these hardware capabilities. So that's what abstractions mean. I have abstracted a layer based on what I have here, so that now I could install Ubuntu, or I can install maybe Windows 7, and I can run whatever applications. So now I've got actually 3 operating systems that are appearing to be operating at the same time on one machine or one layer of hardware. This is the hosted model, okay? This is how probably most of us, if you've got your own laptop, your home computer, this is how you're set up if you're doing virtualization. Now let's go to a server environment, or bare metal. It's called bare metal. A server environment looks a little bit differently, okay? Well, we start out with the same layer of hardware. Now, typically in a server, you're going to have much more hardware. You're going to have a lot more processing power, a lot more memory, a lot more storage, typically multiple networking cards available, and a lot of I/O ports. Now, what you see differently here in this bare metal environment, that you don't see the blue layer we had before with which had an operating system. No, because our virtualization machine monitor or a hypervisor sits right on top of that hardware, and there's a kernel that's a part of this, especially if you're using like VMware, EXXI, so that now this acts as the host operating system, but it's all kind of built in there together. Then on top of that virtualization layer, it is able to now start divvying up this hardware. So I can have Windows running on this. I can have a Red Hat Enterprise Linux, or RHEL as it's called, server, and then I can have the applications for each of these running. And on a typical server, you can have tens or even up to hundreds of these. It's just depending on how much hardware you have. So this is the bare metal, the one I showed you before. That was hosted. That's a server environment. This is how we typically look. Now, something that we do has become more and more popular within the virtualization environment, and sometimes we used to call it, before it got the name containers, application virtualization. But now we just kind of call it containers. Okay, let's walk through that. What are we talking about here? Again, starts out the same with hardware. Same hardware. On top of that hardware, we can have a hosted operating system, or it could be bare metal. It doesn't matter. And then on top of that, now you see we have something different. We call it a container engine, and that could be Synergy, Docker. Probably one of the most well-known is Docker. Docker is a container engine. Now, what this container engine does, it is almost a encapsulated environment. So it has within itself, it has some of the minimal guest operating system software that it needs, so that they can install the binary files, the library files, and then install applications on top of this. So where now this is it basically will run within itself. So everything is held within that container. Container serves, like I say, is a self-isolated unit that can run anywhere that supports it. So really very modular. You can pick this container up, send it somewhere else, plop it down onto another machine. It could be on a shared drive, or it could be actually, you can run containers off of USB SSDs, wherever. So you see, it's a very containerized environment. Now, from a security perspective, why is knowing this important? Okay, many times when we're from a cybersecurity perspective, we really try to vet the operating systems and whatever applications that's being installed on our network, on our PCs. Okay, we want to be sure that those are secure. We run different types of tests, application or software tests, to be sure of the security. The great thing about this environment, and also, let me go back up, we do a lot of patching, right? A lot of flaw remediation, patching. So when, typically monthly, there's patches that are coming out that we have to do to these. In this environment, many times, that is not done within the container. When there's a security update, basically, we throw the whole container away, and whoever is built that container will provide us a new container, and we plug it right in. So we really don't have to break apart the container to start thinking about what's inside that container. Also, there's a lot of isolation between the container and the hosted system that it is operating on. So these are really, from a security perspective, a more secure model to work in. A lot less work with, like I say, with respect to running compliance scans and vulnerability scans on the app. Because many times there can be hundreds of applications that are inside of this container. So if you've got like an NVIDIA container, and when they update that container, NVIDIA will send you out a new container. You delete the old one, install the new one, and boom, there you go. There's your security updates. So that's the containerized environment, all right? So when we come back, we will get into briefly, again, cloud computing. Hope to see you in our next session.